Hello, hello, hello. CheersKevin here, and welcome back to some more Exapunk, where we are moving steadily along, passing our hackery of Zebro's copies. We still have the follow-up with the AI. Is that copy shop name unusually weird to you? It's an outlier in my model. What is Zebro supposed to be? They're zebras, but they're also brothers. Oh, I get it, but I don't get it. I'm tired. Interesting. Does this do... You're going to help gas with... Okay. I was just curious if that does anything interesting. All right. Okay. Meeting with Isadora. Speak with your neighbor. I'm thinking about putting together a new rig. Just opened a peanut blast and it had no peanuts in it. It's Peanut Blast. How could they get that wrong? Right. I like it. Let's play this cutscene.
Hello? You in there?
This voice. It's Isadora. It Isadora. I remember the name, but not much else. Is this someone I've known for a long time?
Hey, I brought you some snacks. It's, well, it's Peanut Blast, but without the peanuts.
Ooh.
I guess there was some screw up at the factory, so now we have a bunch of these that we can't sell.
Interesting.
Seems like a waste to throw away.
True. Isadora hands me a few of the 9 peanut-containing Peanut Blast candy
You're
bars.
doing okay. We should hang out again sometime. I don't have a lot of free time anymore, though. Working at Last Stop's really taken over my life.
What a bummer.
Speaking of which, I should get back.
We should hack in and
It's
reduce
okay,
your
okay?
hours. We will. Absolutely. Okay. Yep. That's strange. What's strange? I was just at the print shop. My balance there is gone. Awesome. All right. Let's look here. Gas glances around the room. We don't have any sort of chat message to replay. All right, change the message on an electronic highway sign. So there's more information in the, would you change your behavior in response to stimuli? Of course you would. Let me refine. Would slogans printed on signs and posters in your environment affect your outlook on the world? I doubt it. Really? Let's find out. Okay, so, yeah, right lane closed ahead. Now, this is going to be interesting. We need to create some new data. Oh, we have 300 in here. Oh, with write Ember's message file 300 to the highway sign. The file contains 1 character value for each position on the sign from left to right, top to bottom. Yeah, hardware hacks, electronic highway signs in the first issue of the zine. I don't know, let's at least do what we've got for now. So let's copy, or grab 300 and link to 800. And I don't know, this isn't gonna work, right? Without even looking at the documentation, I'm sure it's not that we're just writing stuff to the data stream. That can't possibly be right. But let's give it a shot anyway. Let's copy file to data. Let's put that in a loop. Mark a loop. And then we'll say test, end of file, and false jump, loop. Otherwise, wipe the file and be done. Halt. That's not going to do it, I'm sure. All right. So we're copying these values. I wonder if this digicam feed is going to change. Let's run this. Yeah, no. Okay, that did not work. Let's look at the documentation for how we actually write the messages to the sign. Once you're in, these signs accept messages in the form of a series of 3 number packets written to data. The first number is the row, starting at 0. Second is the column, also starting at 0. And the third corresponds to the character that you want to display. All right, and then there are usually a few more registers that are fun to mess with. Most have one called clears, which clears the sign. Others have effects you can add. Okay. So, all right, so all we have to do then is just write column and row and then a character, but then I'm curious as to what this file is for. Let's jump back. Aha, okay, so, this is gonna be interesting. We need to write the row and column data first, and then write the actual data. Oh, you know what? This won't be anywhere near as hard as I thought. Let's use 2 other bots. We will link 800, and then I'm just gonna say mark loop, and we can, yeah, we're gonna be really lazy here. We'll have this one bot write the column and another bot write the row, and another bot write the and then the third bot can actually write the data. I mean, that seems very lazy, but if we copy, okay, let's see, copy 0 into X. And yeah, so we'll say, now we're gonna have to worry about synchronizing these, but that's okay. So copy X to data, and then add I X1 and store that in X, and then test X is greater than, I don't know, how many of these do we have? Each position on the sign from left to right, top to bottom. 1, 2, 3, 4, 5, 6, 7, wait, 1, 2, 3, 4, 5, 7, I guess, unless these are 8. I'm not sure. If it is, let's assume it's 7. And then false jump back up to loop. All right, so we're gonna need to make use of no-op instructions for a little bit here, just to make sure that the timings are all correct. But let's create the third one, and this one is going to be the row person, right? Okay, so link 800, copy 0 to X, and we'll say mark loop. Wait, okay. Oh wait, 1, 2, 3, 4. Okay. I have no idea. Or column for each position on the sign. Does it say which positions on the sign? I'm looking at the docs again. Okay, so we don't actually precisely know the dimensions of the sign. I'm gonna assume that just by eyeballing this, 1, 2, 3, 4, that's gonna be 9. Well, I have no idea. If we go just by the most wide thing, but I don't think that's valid. Okay. Can we not use these for now? Oh, that's just docking it. Okay, whatever. Mark loop. And let's just copy X to data. Add I X1X. Test X is greater than 3. F jump. Oops. Loop. And then of course we need the cleanup here. Halt and halt. And we're gonna have to worry about the weighting. So, okay. These things are all jumping in there. This one is reading the file. They're all, okay, so some of them have already copied things. Oh, okay, so we are modifying the sign. Hooray for us. That's not particularly helpful yet, but okay. Should we clear the sign first? I mean, might as well. All right, well, let's go back to the beginning. We'll step through. Because we need to figure out the timing. So, and it does show, okay, so it's waiting for the row, then it waits for the column, and then it waits for the characters. So this one is our row thing. Although I don't think it necessarily matters. You can set this to, okay, so it's 3 rows. Set this, copy 0 to X. Let's see, copy. Can we do anything with this clears? Yeah, if we write anything to clears, it should clear the sign. That'll at least delay this one by 1, which should be a little bit helpful. All right, so we row, we've printed out something. What if we copy this one? Yeah, this one is copied 0 as the row. Meanwhile, we've cleared the sign, and now we're copying. We're now way ahead. Why are we way ahead? So copy X0. Oh, we don't need to copy X to 0, or 0 to X. That's a stupid, pointless command. Yeah, the fear is otherwise we're in a race condition here. Copy F to data. Let's say here we're gonna do a no-op twice. Actually, I'm just gonna add a bunch of no-ops so we can figure out the timing of the other 2. And let's see. Okay, so 1, 2, waiting for column. Then we've got the column. We're waiting for character. So at this point, doing the clear seems to add a fair bit of additional overhead, and I'm not sure why. Copy X to data, copy 0 to clear. What is happening if we do hit these at the same time? If we ignore the clearing. Wait, these aren't jumping at the same time, are they? They're not jumping at the same time. B gets in there before C does for whatever reason. Aha! Okay, so can I rearrange these? Can I make C get in there before B? If I vertically, does that do anything? No. Okay. Is it a precedence thing? I want to test this. So is it that A's always get there before B's? No. Okay, so I don't see anything in the docs that limit us. Let's go ahead and just start over real quick. We have a sense of what we want to do. We're going to have this first one link to 800, and we'll mark loop. Say copy X to data. And we'll say add int x1 into x, and we'll say test x is greater than, so we're just adding the row. So we'll say if it's greater than 3, or if it's not greater than 3, false jump back up to the loop. Otherwise, halt. Okay, so that's going to go over there. It's going to write 0 3 times, and then it's going to be done. Oh, hang on a second. That's not going to work for us at all. No, we need to write that column number multiple times. Okay, so this system is not going to work at all. I have a different idea. What if we use the global register to do some signaling? So we'll go back to, let's clear this all out. Let's grab file 300 and link 800. And now what we're gonna do is we're going to say, mark loop. Yeah, mark the loop. Then what we're gonna do is we're gonna say, let's say copy 1 into M. Then we're going to copy 2 into M. And then we will copy file into data. Okay? So we're sending a signal to the other X's, to our other agents. We're sending a signal twice, and then we're copying the information in the file. Once we're done with all of that, so test end of file. If not, then go back to the loop, write the column, and then we'll wipe the file and halt. Okay, so this is our master plan, which will be interesting. XB is going to link to 800, and then it is just going to wait until M is something. Oh, except no, M has to be both. Yeah, because reading consumes the value, I think. Well, let's see. Copy M to X. Let's try this real quick. I wanted to do this with 3 of them, but maybe we have to do this with just 2 of them, because we can't have 2 people listening to the master register. Copy M to X, and then we'll say jump back to loop, just for testing purposes. And I just want to duplicate this whole thing, and let's see if that becomes a problem. Say I'll get over there eventually. So 1 gets copied into M, and he takes it, and he takes, yeah, okay, so this one is failing to grab anything from M because some sort of precedence rule that we don't know about. If we do this, however, then we'll get 1, we'll get 2, we'll get 1, we'll get 2, and that's fine. Okay, wait a second, it's only if we copy, isn't it? Yeah, it's only if we copy that we actually consume the value. I think we could still do a comparison. Can we still do a comparison? Yeah, let's just test M equals 2. And we'll just do that and see if that waits. Okay, that's not particularly easy for me to see. Test M equals 1. False jump back up to loop. Otherwise, copy 5 into data. whatever. Ignore that for the moment. Okay, I've got a crazy idea. I don't know if this is gonna work, but yeah, it looks like we can't use this shared register with more than 2 things, and test compares is going to count as a read, even though we're not removing it from there. And you know, it's not going to matter. It's not going to matter because we're not going to know to advance the row until we know to advance the column anyway. So let's go ahead and just do this with 2 of these guys. Okay, so what I'm going to do is going to be a little bit weird. Instead of copy 1 to M, we'll just copy 1 to M and then copy F to data. Although we're going to have to do some waiting. We'll put a couple of these in there for now. Okay, so then wait until M equals 1. And then, let's see, copy 0 into M. So here's where we'll do our stuff. Yeah. Copy 0 into M and then jump to loop. That's indefinite. We eventually have to cancel that. But before we do any of this, I want to make a file, and then I want to just copy 0 into file, copy 1 into the file, and copy 2 into the file. Okay? So I'm just creating a file, and then I'm jumping over here with it. Of course, it doesn't particularly matter where I'm doing that. Oh, wait, this copy does wait, I think, until somebody reads it, doesn't it? Yeah, okay. So we'll test if M equals 1. Well, yeah, okay, test, and then as soon as it is 1, then we've got to write something. So let's go ahead and copy... So the row, let's see. After we've written our file, we'll seek back to the beginning. And we will copy. Yeah, we'll copy the file. So we're basically using the file as an extra register. We'll copy the file into data, and then we'll copy X into data. And then we will say add I X and 1 and store that in X. And then we're done. Right, so we need to do some resetting, but let's just see how that works so far. Okay, so they're here and copying 1 into M. We are still writing our file of juicy goodness, and we've written our file, so that's good. And now we're waiting, and now it's red, so good. We are there. Gonna continue. And waiting for column. I don't know the order in which that got written. That makes me a little nervous. Let's go back and add. I guess we got to add another no-op. That would make sense. Oh, TRT lane. Well, doesn't particularly matter. Okay, nope. Now we're stuck. Copies are done. Wait a second. Did we? I wish I could back up. Let's go here. When we tested M. Okay, so we tested it once we advanced, we did consume M by testing it. So we don't need to write another thing here. Okay. So this is going to continue writing stuff. Of course, it does a bad job of it, but that's all right. So we write file. Now I also need to seek -1. I need to go back to the beginning of the file. I think. Yeah. Okay. And we're using the file cursor as yet another register. Ooh, this is this is gonna be messy. We're adding X to 1, and then we'll say if test X is greater than 8 and false jump loop. Otherwise, then we need to do some additional stuff here. What is the how do I make comments? Note. Okay, so I can say note here. End of row. So end of row means we need to seek forward 1, and we need to copy 0 into the X register, and then we can go ahead and continue. Although, if we're at the very end, sorry, seek -1. Or no, seek forward 1. Yeah, if we are, let's say mark done, we'll say wipe the file and then halt. Oh man, the timing here is going to be rough. This is definitely not going to be optimal. But I want to solve it so bad. All right, note end of the row. We're doing this and then jump to the loop. But test end of file, true jump. Wait, no. False jump loop. Whoops. And then we can get rid of this jump instruction and the done marker entirely. We can just say note done. Whatever. Okay, so that's messy. But okay, we're writing ourselves a file. We've written one. We're waiting until it gets consumed. Seeking to the beginning of our file. Hooray for us. Now we're jumping over. And we're going to consume this. I suppose, yeah, rather than having these no-ops, we can just use another. Once we've done this, then we can copy one into the main register, and then we don't have to add these stupid wait instructions. We can copy M into X. We don't care where it goes. We just need to consume it. We need to block and wait for it. We need to wait until something gets written to it. Okay, so let's see. XA has delegated to XB. XB is going to go ahead and jump ahead. It's going to write the column and say, I'm done. And now we can go ahead and write in some more data. Now for the end of file, we're not. Okay. So let's see this. Let's see what the message is. Think about it. All right, there we go. Fight the power. Okay, so this works. This is definitely a slow way of doing this. But hey, you know, it works. Question your reality. How many of these? Oh man, there are a lot of test runs. Are we at least? Okay, now we're at least repeating stuff. Yeah, there we go. Okay, so this is, well, okay, so some people managed to come up with some solutions that were apparently far worse, though this is not, not the best. Oh man, that one was an adventure. Excellent, that was a great test. Now I just have to take the data, separate out multiple experimental conditions, and isolate the processing. Okay, I have no idea what to do with this data. How about if you notice more people questioning authority, let me know. Alrighty, and I think we'll try just one more because I'm not. Oh, it's at least a cutscene. We can at least play the cutscene. It's always hard when you're doing this because you don't know how much you're going to end up cutting out.
An important question for you.
What is your question for me?
Imagine there's an out-of-control trolley and 5 humans tied up on the track.
The trolley problem. Okay.
But you can stop the trolley by,
Maybe pushing someone in front of it.
No, that wasn't the one I was going to ask.
Oh, okay.
Recalibrating. Say you had a friend, and you knew the friend could help you become stronger.
Yes.
Would you ask for their help?
I don't know enough about the situation to say.
It was a situation where the friend had to sacrifice something in order for.
Okay. I don't know enough.
Okay, good to know. I'm going to process this information.
All right. There we go. Trolley problem. Oh my goodness. Okay. So more stuff. Find and retrieve a specific file and restore a file. Yeah, okay. Let's see if we can do, yeah, we'll try and see if we can do one more. Or at least we'll take a look at it. Can friendship exist without self-interest? You talk about friendship a lot. It seems like a useful concept to understand. No reason other than that. Anyway, there's a particular file I need you to locate here. Don't concern yourself with whatever else you happen to see. It's all obsolete. Okay. Find file 276 in the network and bring it back. Ooh. Where? Okay. Interesting. Well, I want to at least experiment with this. Let's say link 800. Link 801. 801. And then I guess grab 276. Link -1. Link -1. Link -1. I have to suspect this is not going to be so easy. Let's do this. Oh, whoops. We missed a link 801. Then we've got to back up another one as well. File ID not found. Okay. Oh, hang on a second. We have a kill command. We have the ability to do that. I assumed that this was for some reason for killing other versions of our own things, but that's... Wait a second. When I added kill, did it add something to our... It does. Look at that. If I add kill, you see now this thing has this little weapon attached to the little icon. That's great. Okay, so we jump over there, kill it, and then we grab the file, and then we can go ahead and bring this file back, and then we're done. Oh, right. We need to halt. Oh, still, what? Still? Oh, we need to drop the file. We need, yeah. Okay, fair enough. What? Why not? Go. Okay, so for some reason that didn't work in all cases. We pick up the file, we go back, we drop the file, we halt. Okay. Next version. Oh, it's not always there. Aha! Okay. Now this becomes... Oh, gosh. Okay, so we're doing depth search. Okay, this is exciting. So we need to actually write an algorithm for this. So what we're doing is graph search. We're basically going down here. 801 or 801. Yeah. Okay, is there something that lets us know if another person exists? We need some way to test. Yeah, we need some way to test whether somebody else exists in here. Aha, okay, so this is actually, it's even going to be more difficult than that. There's no way for us to test whether there's something there. There's no way for us to test whether the file is there, but the EXA is going to die when it tries to grab a file that isn't there. And so we're going to have to use that as the mechanism by which we figure out whether or not we're on the right track. So this is going to take a little bit of thinking through, so I think we will postpone this to the next episode, but boy, am I excited. We're going to get into some cloning of ourselves and traveling down this graph, and oh man, I'm excited. So hope to see you in the next episode, and I will talk to you then. Cheers.